Hello, my name is Dr. Dan Wedding, and this is DrWedding, VB19, Classes. In the past, if a programmer wanted to hold different types of information about an object, such as a name, an age, and a GPA, the programmer would need to use parallel arrays. Parallel arrays are multiple arrays, and the programmer knows that the first element of each array represents the first item. The second element of each array represents the second item, and so on. Below, there are 3 arrays declared, and each has 4 elements. Element 0 of all 3 arrays represents the information about Mary Smith. Element 1 of all 3 arrays represents the information about Bob Jones. Element 2 of all 3 arrays represents the information about Dan Miller. Lastly, element 3 of all 3 arrays represents the information about Steve Brown. There are a lot of problems with using parallel arrays. 3 big problems are highlighted below. The first problem is maintaining the parallel structure of the arrays. Assume you want to sort these students by age. You would need to run the age array through a sort routine. But every time you swap an element in the age array, you would also need to swap the same elements in the name array and the GPA array. The second big problem is jumping from one array to another. Assume you want to know the name of the student with the highest GPA. You would need to run the GPA array through a routine to find the largest value. You would also need to keep track of where the largest GPA is, so you could use it to print the name in a different array. The third big problem is there is no indication that the program is using a parallel array. Someone who is looking at this code for the first time would have no way to know that Bob Jones is 19 years old or that Dan Miller has a 3.1 GPA. To make it easier on yourself and others, you should consider using a class instead of parallel arrays. Think of a class as a container to organize data, just like a lunchbox can hold your lunch. Your lunchbox is a single item that holds multiple smaller items. A class variable works the same way. It is a container that can hold other variables. You can customize the class to meet your needs. Instead of parallel arrays, you can make a student container that can hold an image, a string, an integer, and a double. Below is an example of what a class variable named student might look like. When you put the student information into the class, it will be easy for another programmer to know that all of this information is about one person. You use dot notation with classes, just like you use dot notation with a button or text box. Assume the class variable below is named student315. If you want to change her age and GPA, you can use the commands below. Just like you can declare an array of integers or doubles, you can also declare an array using a class variable. You can still update or retrieve data using dot notation. You just need to include the index just like you would with any other array. The command to display Bob Jones's age is shown below. Classes are easy to maintain. If you want to sort the students by age, you can use a sort routine. When you swap 2 students, the class will keep the information organized for you. There's no need to swap the contents one at a time. If you issue the following swap commands, Mary and Bob will switch places. It is very common to use information about a person to teach classes. Therefore, I will not be doing that example. The example I'm going to demonstrate will perform the following tasks. Create a playing card class called Card. Create an array of cards and call this array Deck. Write a very easy subroutine to load the card information into the deck. Write a very easy subroutine to shuffle the deck. Write a very easy subroutine to deal cards from the deck. With this information, you can start to write a very simple game of war, blackjack, or if you're really ambitious, poker. An example is always the best way to learn, so let's get started. I've opened up a new project. First, I'm going to embed all the card images into the project. I covered how to do this in video number 16. These cards, as well as other images, are available for free in the link in the description below. First, I'm going to open up the project, select Resources, and Images. Next, I'm going to drag and drop all the images into the project. The list of cards is now shown in the Resources in the Solution Explorer. Now we're going to create the class. Before you do this, make sure you select the name of your project in the Solution Explorer window. That way, when your class is created, it will be visible in this list. If you create the class while My Project is selected, the class will be created in the My Project directory, and it won't be visible on this list. Your program will still work, it'll just be inconvenient. So, make sure you select the name of the project, then go to Project, Add Component, and select Class. I'm going to rename this class to be Card. And I'm going to add it. The Card class has now appeared in the Solution Explorer window. Now I'm going to add some variables. These variables will be the properties of this class. These variables can be any type that you want. They could be booleans, integers, and they even could be arrays. Underneath the properties, I've added a single method. A method is a special subroutine that is used by the class. This method is called card information. It has a message box that will display the rank and the suit of the card. These methods in the class can be as complicated or as simple as you want, and you can have as many of them as you wish. Now let's go to the form and start using this class. First, I'm going to add a variable. I will declare it just like any other variable with one small exception. The command is dim temp card as new card. The only difference between creating this type of variable and the standard variables we've been using so far is the word new in front of the type card. This creates a new instance of a card class. Inside of form load, I'm going to assign values to the properties of this new card. Just like any other object, if you want to access the properties, you can do so using dot notation. For example, if I want to change the card's rank, I can say tempCard.rank equals and assign it a new value. Once the properties are assigned, I can use the method that was created that will show me the card's information. Let's run this program and see what happens. When the form loads, you're going to see the pop-up window that's in card information. My card is the 3 of hearts. Now that you've created a class and used it in a project, we're going to take it one step further and create an array of the class. The array in this example is called deck. It has 55 elements. The elements are 0 through 54. I'm going to skip element 0 and only use elements 1 through 54. If you're wondering why I have 54 cards in my deck, and that's because there are 52 cards in a regular deck and I also have 2 jokers. You should also notice that the word new is missing in front of the word card when declaring the array. That's because the new has to be issued to every single element in the array. That's the purpose of the for loop that's in the form load. It issues the new card command one at a time to each element of the array. Each one of these class variables has 6 different properties. If I were to manually fill them in one at a time, I would have 324 lines of code of just assigning values. Instead, I've written a program to do this work for me. I first start off with a character array with all the words that I'm going to have to type in, such as ace, 2, 3, 4, and so on. The first loop sets up the spades. J will go from 1 to 13. When J is 1, it will assign a back, then the front, the rank value, which is equal to I, the suit value, which I'm making 1, the suit, which is the word spades, and the card rank, which is pulled from the card rank string array. To save a lot of time, you'll see that the cards were named C1, C2, C3, D1, D2, D3, and so on. The letter is the suit of the card. C is for clubs, D is for diamonds, S is for spades, and H is for hearts. The cards are then numbered 1 to 13. To load the file into the array, I start off with the letter representing the suit. In this example, S for spades. Then I turn the loop index, I, into a string and concatenate or glue it on to the S. So the first time through the loop, it'll be S1, then it'll be S2, S3, and so on. I then tell the resource manager to retrieve file S1 or S2 and load it into the array. I then repeat the process for the diamonds, the clubs, and the hearts. Lastly, I manually load in the red joker and the black joker. If you want a copy of this code, the link to it is in the description below. Now all I need to do is call assign deck from form load. I'm going to minimize this to get it out of my way. Now that the card class has been created and an array of cards has been declared, we can start to use these cards in a real program. I've created a form with 2 picture boxes on it, a button, and a label between the 2 picture boxes, which currently doesn't have any text. When I press play high card, a card will be dealt to player 1 and player 2, and the label in the middle will say which player is the winner. First, an integer called top card is created. It's assigned the value 1. Top card is the card that will be displayed on the screen. As we use the cards, top card will be incremented. When top card reaches 52, all the cards in the deck are used up and the play will stop. First, there's a try catch. This is for safety in case the array gets exceeded. Inside the try is an if block. If top card is less than 52, there are still cards left in the deck and we can deal them out. If top card is greater than or equal to 52, the else is tripped and a message box displays out of cards. However, if top card is less than 52, the top card is dealt to player 1, and its rank value is saved in a variable called player 1. Then, because the card's been used up, top card is incremented by 1. The new top card is given to player 2, and the rank value of this card is saved in a variable called player 2. Because this card has been used up, top card is incremented by 1. Lastly, an if statement is used to determine the winner. Let's run this program and see what happens. Now that the button can deal and determine who the winner is, we'll need to shuffle the deck. In order to shuffle the deck, I'm going to need a random number. Therefore, I have to add randomize to form load. This will mix up the pseudo-random number generator. The subroutine, shuffle the deck, will go through the deck of cards one at a time using a for loop. Each time, it will get a random number from 1 to 52 and swap the current card with that random card. This subroutine truly demonstrates how powerful a class is. If I would have used 6 parallel arrays instead, every time I swapped a card, I'd have to swap the front, the back, the suit, the rank, the suit value, and the rank value. This would have extended the complexity and length of this program. A class will swap all 6 properties each time as a single unit. Now that we have a subroutine that will shuffle the deck, we just need to call it when the form loads. Let's run the program now and see what happens. Now that we have the class working, we can shuffle the deck and deal the deck. We can make some minor modifications and make a working program. I've added 2 more buttons, one called Shuffle and one called Restart the Game. I've also added a counter for each player to keep track of the number of times they've won. I've added 2 variables, player 1 score and player 2 score, and inside of form load, I've printed them to a label. And for neatness, I printed the back of the cards on the picture boxes. In the play button code, I've incremented the winner's score and updated it on the form. Behind the shuffle button, I call the subroutine shuffle the deck and reset top card to 1. And then I print the backs of the cards to the 2 picture boxes on the form. Finally, behind the restart button, I reset the scores back to 0, print the backs to the picture boxes, print the zeroed out scores to the form, call shuffle the deck, and set top card back to 1. Let's run the final program and see what happens. When the program starts, you can see the back of the cards, and you can see that both players have 0 wins. As we start to play the game, the number of wins for each player starts to increment. When we run out of cards, we can reshuffle the deck and continue the game. If we want to start a new game, we can restart the game, and the scores will go back to 0, and we'll see the backs of the cards again. I hope this video has helped you learn how to create and use a class variable. In review, parallel arrays are obsolete. I'm sure someone out there will tell me why I'm wrong, and even give me an example of when they're better than a class variable. But I still believe they are not very useful anymore. In the past, This was the only option for someone who wanted to generate what is now a class. These are multiple arrays that a programmer needs to keep aligned. It was the programmer's responsibility to make sure that element 0 of all the arrays represented the same item. Element 1 of all the arrays represented the same item. Element 2 of all the arrays represented the same item, and so on. Keeping the arrays in alignment was complex and difficult to maintain. Parallel arrays also had the further problem of not being clear. A programmer looking at the code for the first time may not realize that some of the arrays are parallel and some are not. Due to the limitations and complexity of parallel arrays, class variables were created. When creating a class, make sure you select the project name in the Solution Explorer window first. This will put the class in the main list. Select the Project drop-down menu, and then select the Add Component option. Note, Add New Item will open the same window. When the window appears, select Class. Rename the class at the bottom of the window, and finally, press the Add button. A class has two parts, the properties and the methods. Properties are the variables that describe the class. They can be any type and can even be an array. When declared as public, the rest of the code in the project can access the properties with dot notation. Methods are custom subroutines that work on the class. They can have values passed to them using by-ref and by-val. When declared as public, the rest of the code in the project can access the methods with dot notation. When declaring a class variable, you need to use the new operator to create an instance of your class. New must be used on every instance of your array, so the new operator is used inside of a loop for an array. When you use a class variable, it's just like using any other object, such as a text box, label, or button. The object's properties and methods are accessed using dot notation. If you're working with the entire class variable, you do not need to use dot notation. In this example, the cards are shuffled. When the cards are swapped, all of the properties are swapped with the card. There's no need to manually swap all of the properties one at a time. If you find these videos useful, please like and subscribe. It is the only way I can continue to make these videos.